Now that we have understood the concept of bounds, right? Bounded below, bounded above, bounded both above and below, and then we have also seen least upper bound and greatest lower bound. Let's look at some theorems. Okay, every function defined and continuous on a closed interval is bounded. That is, if f of x is continuous on the closed interval a to b, then there exists m belonging to the set of real numbers such that magnitude of f of x is always less than for all x belonging to the closed interval a comma b. Okay, if we want to look at it graphically, you will see something like this. So let us say this is a, this is b, and any point on the curve will always be less than or equal to, and this is m, and let's say this is m. Now let's look at the next theorem. A function f of x which is continuous in a closed interval attains its bounds. That is, there exists x1 belonging to the closed interval ab such that f of x1 is equal to m, that is LUB, and there exists a point x2 belonging to the closed interval a comma b such that f of x2 is equal to m, and this is your greatest lower bound. What this basically means is that if you have a curve and if you put your pencil on the curve anywhere without lifting it, you can reach the upper bound, and similarly you can reach the lower bound without lifting the pencil. Let's look at the next one. If f of x is continuous at x equal to a and f of a is not equal to 0, then we can find an interval a minus delta to a plus delta such that for all x belonging to a minus delta comma a plus delta, this is a open interval, f of x has the same sign. So basically, again, look at it from graphical point of view. If you have a curve and f of a is not equal to 0, that means it never touches or crosses the x-axis, then naturally in the thereabouts of that point, right, a, and this is f of a. So f of a is never 0, that means in its neighborhood the function has the same sign. Now it could be on this side or on this side or in any of the quadrant. Okay, fourth one, if f of x is continuous in the closed interval a comma b and f of a and f of b have opposite signs, then f of x vanishes for at least one value of x belonging to the closed interval a comma b. That is, there exists c belonging to the closed interval ab such that f of c is equal to 0. And looks all complicated, huh? But once you look at it from a graph point of view, it's very simple. It goes something like this. It doesn't matter how the curve, the curve goes, whether it is like this, whether it is like this. Now let's take one curve, any one curve. Let's say the curve goes like this. Okay, now if you have 2 points, let's say this is f of a and this is another point f of b. If they are of opposite signs, if they have opposite signs, now here this is positive and this is negative, right? So since they are of opposite signs, what this theorem is saying, that you will have at least one point where f of x is equal to 0. So if we say this is c, then we can say f of c is 0. Now why at least one point? Because there can be more than one also. Simplest example is what? Sine, right? Here it is 0, here it is 0. So here a point here and a point here will have opposite signs. So in that interval, in that closed interval of a and b, you will have a point where f of x becomes equal to 0. Or it could be something like this, right? So here you have more than one, that is 2. In case of sine, you have n numbers. Okay, next one, a function which is continuous in a closed interval a comma b takes every value between its bounds at least once. What this means is that, something like this you have. Now what this theorem is saying is, and remember this function has to be continuous. If it is continuous and you have a and b, then the function will take each of the values in between a and b at least once. So here once, here once, but here twice. So that is why at least once it will take that value. And remember, these are infinite values because we are talking of real numbers. Just remember, when you say real numbers between 0 and 1, here you have infinite numbers. Okay, so these are the theorems. Again, understand these carefully. Bye for now.